So in this video we're going to be taking a look at a practical application of a 2D array, and we're going to do that by creating a full tic-tac-toe game. So something that you could play in the terminal, by yourself if you wanted to, be both the X's and the O's, or you could play with an opponent, such as a friend or a family member. So we're just going to go from the ground up. I haven't written anything in here yet, and we'll get going. So we're going to want to make a class and call it Tic-Tac-Toe. And this is going to be a class not like a driver, so it's not going to have the public static void main in it. This is going to be more like the monster class, the song class, the dice class, all of those classes that we've seen before in the past. In the most recent assignment, the person class. So it's going to be an instance of tic-tac-toe, or it's going to be like technically the blueprint of how to make a game of tic-tac-toe and all the things that such a game can do. So first, we might want to be able to represent the board. So what I'm going to do is create an array of strings, and it's going to be a 2D array, so it's going to have both these brackets here, and I'm going to call that actually just call it board. That's what it is. That's a much shorter name, easier to type. We'll call it board. And we know what the board's going to look like. So the board has 3 rows. So there they are. And each row itself is an array. And I'm going to put these spaces in here, because each space is initially empty. But I don't want to use the empty string or the null string, because those won't print quite as well later. So they'll either be empty, or eventually they'll be filled with X's or O's. So there we go. There's the board. And let's actually do one more thing. So we don't want people on the outside to be able to stick their hands in and mess with the board. We want only the tic-tac-toe game itself to be able to do that. So we're going to set it to private. Alright, that's the board. So before we go any further, let's create a method called printBoard. And that's going to be void. And what might this be useful for? Why might we want to define this? Well, we're going to want to be able to print what the current board looks like to the screen, so that we know what we're dealing with. And when you're playing, you can actually see what's going on. So what we'll do is we'll print this out, we get it to look like a tic-tac-toe board, and then we can keep going from there. So let's go through and let's just use the enhanced for loop first. I don't see a reason why we shouldn't. And, well, we'll end up switching, I think. But let's use the enhanced for loop just to get us going. So for row in board, for entry in row, let's print out the entry. Okay. And let's add a little pipe after it. And we'll save it. Ooh, I do not want to overwrite. Save. We got bunches of stuff in here, but I'm going to make a new folder. Go into there, save it. Alright, cool. So we'll do that. So those will be the little vertical bars. Hold on one second. So we know what a tic-tac-toe board looks like. It's got like this sort of hash pattern. So these ups and downs I don't know why I pulled up a sheet of paper. Let me just pull up Paint so you can see a little better. So we got like this, right? That's tic-tac-toe. These little pipe characters. This one here. We're going to use that to draw these. So we're going to have a blank space, a pipe, a blank space, a pipe, a blank space. That's what this is. Then once you reach this, right, you want to get on the next line. So we need a new line. We need a new line between rows so that we can start all over again. Right? Okay. So let's see what that looks like. Let's compile it, see if there's any errors. Oh boy, there's not. And we can make a tic-tac-toe board. Oops. Oops, I did not mean to put public in front of that. Okay. So it's compiled. Now let's do this. T.print board. Alright, cool. So we're getting close. So what else do we need to have between the rows? We don't just need the space, we also need this line, right? This has gotten kind of messy. Let me... Okay. We also need these lines. So we have the vertical lines. We need these horizontal ones. So we can just do that here. Oops. We're going to use this little dashed line. And then when we're done, actually at the beginning, you need to put a new line as well. So this will be on its own line. Alright. Starting to look like a tic-tac-toe board. Let's see, how many of these do we actually need? We need one for every character. So one, that's empty space, the pipe, empty space, the pipe, empty space. So we don't need these three. Okay, so there's our tic-tac-toe board. But as you can tell, there's something not quite right with it. Our board... Let's erase a little bit of this. Our board has a line here, has a line here, and a line here. We don't want those two lines. And that's happening because at the end, after every space that we see, we're drawing a pipe. We don't want this pipe. And we don't want this. So how might we get rid of those while leaving the ones that we do want? So the answer is to actually change up how we're iterating through the board. So we're going to need to get rid of this and instead do the normal for loop that we're more familiar with. So we're going to start at row equals 0, and while the row is less than the length of the board, we're going to keep going up. Right? And what we'll do is we'll split this. So we always want to print the entry, but we only want to print this thing, this pipe, if something is true. So we want to print the pipe, so this would be 0, 1, 2. And the length of the thing is 3. So, this is the first loop, this is the second loop, this is the third loop through. So when or when row is 0, we want to print the pipe. When row is 1, we want to print the pipe. But when it's 2, we don't want to print the pipe because we've reached the end. So what we can say is if row is less than board.length minus 1. Does that make sense? Let's try that. Oops, I forgot my... Oh, we're also going to have to fix some stuff up. We don't have an entry anymore, right? I guess we do. We just need to do this instead. So get the row at that position in the board. Alright. Yeah, let's try it. Alright. Oop. Okay, my bad. That would be... We put it in the wrong loop. So let's think about what happened here. So we still got all the pipes, but we didn't get this row of pipes. So it doesn't matter what row we're on, it matters what column we're on. So we're going to have to change this loop as well. So we're going to keep looping while board. We can just grab the first one because it is a square. So basically, for however many columns there are, keep looping. This thing is now going to be board, row, column. Right, so get me the thing at row whatever, column whatever, and that's the entry. While the column is that. That should fix it. Oops, my bad. Okay, there we go. So get the first row from the column. However long that first row is, that tells you how many, or get the first row from the board. That's what this says. However long that first row is how many columns there are. Subtract 1 from it so that we don't add a pipe to the last column. Okay, there we go. That's what we wanted. So now we've got rid of these pipes over here, and we just need to get rid of this last dashed line down here. And we can do that the same way. So if, this time we're going to use the row. If the row is less than the board's length, which is how many rows there are, minus 1, then do that. Alright, cool. So that's a tic-tac-toe board, right? More or less, you can see what's going on. That's about as close to a tic-tac-toe board as we can get and still be in the console. And the cursor's right here, and that's kind of ugly. So what I'm going to do is after this loop is ended, which is right there, I'm going to put another new line just to clean that up a little bit more. Okay, so now we can print our tic-tac-toe board. So that's going to help us later to actually visualize what it is that we're doing. And believe it or not, this was actually one of the hardest parts of this whole problem. So, now that we've done that, it would be nice if we could actually put an X or an O in one of these squares. So let's write a method that does that. It's going to be public because you're going to want to be able to call it from the outside. It's not going to return anything. And we'll call it mark space. And what information do you think mark space is going to need in order to mark a piece of this grid? So if you want to put an X here, what information are we going to have to give Tic-Tac-Toe in order to do that? So it needs to know, one, what you're marking with. We want to mark with an X, not with an O. So let's go ahead and put that, the mark. What else? Well, it needs to know where you want to put it. So let's do int row and column. It's always good practice to do row and then column. So there we go. So it's public so we can see it, doesn't return anything. It's called mark space. It takes a row, a column, and a mark. Now this is really easy. It's one line. Just the board at the row and the column that we gave it. Set that equal to the mark. Done. That's it. So we'll make a tic-tac-toe game, print the board out, you see it's empty. T dot mark space. Let's mark the middle square, so that's 1, 1. And we want to mark it with an X. The X always goes first. There we go, no errors, perfect. And we print the board, and we see now there's an X there. So let's do that again. Let's mark the space right here. So that's 0, 1. I'll mark it with an O. Print it, and there's an O there. So we don't have to worry about how the board's printed anymore, because we already went through all that process and all that headache. That's done. It's a black box. We don't have to think about it. And now we also don't have to think about how we're going to mark the spaces. We can just tell it where we want it to mark, and it'll do it. So we can print the board. We can mark the spaces. What else might we want to know how to do? Well, let's look down here and see what happens if I did t.mark space 1, 1 with an O. So I just overwrote the X. So it might be nice if we were able to check if a space was free or not. So let's do that. This is going to be a Boolean, right? It's going to return either true or false. Is free space. And you're going to have to give it a row and a column to check. And it's just going to return the board at that row and that column if it equals the space. So if whatever is at the row and the column that we gave it is the space character, this is true. So is there a free space? True. Otherwise, false. Another one-liner. Really nice. So let's test that one. Alright, let's print the board. Let's put an O there. Alright, cool. T dot is free space 1, 1. False. T dot is free space 1, 2. True. Cool. So now we can check if a space is free. We can ask the tic-tac-toe board if the space is free before we mark it. And you're probably wondering, well, why don't we put this check inside of here? Well, it's not really the board's job to worry about if a move is legal or not. That's the job of the game. The game is going to handle all of that logic and make sure everything plays out right. The board is just going to have all the tools that we need in order to do that later. So we can check if a space is free, and we can also mark a space. Two separate things, but later they'll be used together. So what else do we need? What else should the board be able to do? What's going to make this easy for us later? Well, it should probably tell us if the game is over. That's going to be public. It's going to return a Boolean, right? Either the game is over or it isn't. Is game over? Okay. And what are the different ways that a tic-tac-toe game could end? Well, it could end because a player won. So there was a winner, or because there are no more moves. Those are the two ways that a tic-tac-toe game could end, right? And we could refine this one down a little bit. To say that there are no more moves means that there are no more empty spaces, right? And if there are no more empty spaces, that means there are no more spaces within our board. Every one of these is either an X or no. So let's go ahead and check for that, and we'll come back to this winner thing in a second. So if we want to check if any of these are spaces, what we'll do... Actually, let's go ahead and worry about the winner thing later, and we'll finish up with this nice easy problem here before moving on to actually making the game. So in order to solve this, we're actually going to want to make another method called getWinner. And what this method is going to do is return the winner of the game. And if there isn't a winner yet, it'll just return 0. And we could leave a comment up here that says just that. So let's do that. Or 0 if no winner yet. We could probably do that on one line, actually. I guess. Yeah, there we go. Alright. So there we have it. So now we got to solve this problem. How do we know if there's a winner? And then, even further, how do we know who it was that won? So what we're going to say is the X is the 1 and the O is 2, because the X always goes first in the game of tic-tac-toe. And let's go back over here, clear my board. So you've played tic-tac-toe before. So what is a way that you could win? Well, X can win if they end up in a situation like this, right? So you get them all across. Same thing with O. 3 across will win you the game. So let's check for that. Let's see if we got 3 across. So lucky for us, these are sort of grouped into rows. So we just need to check row by row and see if every item in that row is an X or if every item is an O. So let's do that. So for each row, let's put a space here. For each row in the board, then for each entry in the row. So we get the row, and then we're going entry row by row. So for every row that we look at, we're going to keep track of the number of X's. So that's the X count. It'll be 0. And you can keep track of the O count. So that's how many X's we have in the row and how many O's we have in the row. If the entry is an X, we'll add 1 to the X count. If the entry is an O, add 1 to the O's count. So all we're doing is we're stepping through. So let's say we had something look like this. We go through one at a time. So we go to this entry first. Is that an X? Yeah, so the X count is 1. You come to this one. Okay, now it's 2, 3. and the O count is still 0. If we were to see this row, see an X, okay, see an O, add one to the O's, see an X, add one to the X's. So in this case, this one wins, that one doesn't, because there are 3 X's. There's also 0 O's, but this matters less than the fact there are 3 X's. So after you've checked a row, a full row, you should check and see if the X count is 3. So this is where we're iterating through the row. So right after we've done that, if X count equals 3, return 1. Because 1 is X, remember? That's player 1. If the O count equals 3, return 2. Player 2 has won the game. And this return will break us out and we'll stop looping. Otherwise, we're going to go back and we're going to check the next row. So let's leave a comment here. Check for 3 across. And let's go ahead and put, oops. So that we can test this, let's put a return down here and it's going to return 0. Let's comment this out, so we're actually not using it right now. Perfect. And we want to make a tic-tac-toe game. Let's print the board. And let's put X's across this middle row. So T dot mark space 1 0. Let's see, that's the row. 1 2. There's all the X's. T dot get winner 1. So see, it worked. It figured out that X had won the game. Let's make another board. And let's do it again. This time we'll do it with O's and we'll do it at that bottom level. So T dot mark space 2 0. O. Okay, let's print the board. Okay, so we don't have a full row yet. So let's see if there's a winner. There is no winner. Now let's mark that last space. Oops. Let's see if there's a winner now. And 2 is the winner. So we're now checking these acrosses. Alright, so what's next? So we can do the acrosses. What more might we need to do? Well, what about the downs? That's something we should be able to check. So let's go back to our program. So this whole thing just checks the across. Check for 3 down. So we're going to want another loop. In fact, we can just copy and paste what we've got up here. Because this looks like it's almost the exact same problem, right? Imagine if, well, let's do this. Okay. So this is the problem we were just solving, right? Where we went across. Just rotate it. it's just a rotated version. Instead of checking the rows first, we're checking the columns. So, column. So this actually won't do what we want it to do because you're still getting the row, right? Boop, boop, boop. We just changed the name. So we're going to have to change this up a little bit. We have to do int column equals 0, while the column is less than board at 0. So however many columns there are, then add 1 to the column. Alright, then we got our X count, our O count. That's good, we can leave that. Then here, we need the entries, but we're not going to be able to do it this way either. We're going to have to keep track of the rows. So while the row is 0, however many rows there are, there we go. So it's just our normal friendly old for loop. And to keep things nice and easy, let's just make a variable called entry instead of renaming both of those. And the entry is just going to be the board at position, row, column. And we're going to go through them columns first and then the rows. So instead of going this way, we're doing a column first traversal. And everything else should be the same. We should be able to test that now. Yeah, no errors. Beautiful. And we'll make a board. T.get winner. There is none. But let's mark that space. Let's print the board. So we put it there. So what we'll do is put one there and there. Oops. So that's at row 1, column 2. We want to put an O. T.mark space, column 0, or row 0, column 2. But first, actually, let's check and make sure there still isn't a winner. Still no winner. Let's mark the space at 0, 2. And print the board. There we go. Cool. So there is a winner. And let's see if the computer is able to tell us there's a winner. And it can. So the winner is 2. Bing, bing, boing. Beautiful. So we can check the acrosses. We can check the downs. Alright, what's the other way that you can win a game of tic-tac-toe? Well, you could have the diagonal. There's 2 diagonals that you could have. You could either get this one, or get this one. And I'm going to erase these 2 arrows for simplicity's sake. So those are the only 2 diagonals that are possible. Alright. So let's try to figure out mathematically how we might check that. That's a little more complicated than just checking the rows, because we don't care about these spaces here at all. And we need these 3 or these 3. If you just have these 3, that's not enough. Or this one, and that one, that's no good. They have to be in this row, or in this this line. So this one's at 0, 0. This one's at 0, 2. This one's at 1, 1. This one's at 2, 0. This one's at 2, 2. So take a moment and look at that and see if you can find a pattern. Is there something going on here? Is there a way that we can connect these numbers? So the one that I think is the easiest to find is this one is 0, 0. This one's 1, 1. This one's 2, 2. So when the row and the column are the same, that's this diagonal. So if you have all of the entries where the row and the column are the same number, then you've won the game. So we can check for that too. Check the, we'll call that one the down diagonal. So let's go and do it this way. So for the row equals 0, while the row is less than the length of the board array, add 1 to the row. And let's see, let's grab our X count and our O count. And let's just grab this thing. Alright, cool. And we actually want this outside of the loop. So right there. And we don't have a thing called entry yet, so let's make that. So at row, in fact, let's just call this X, so it's not confusing. Or I even, because X's and O's, that could get confusing. We'll call it I. Okay, so all I is iterating from 0 to 1, so or 0 to 3 rather, up to but not including 3. So you get 0, 1, 2. And because we're doing I on the board, we're checking this one, and this one, nothing else. So let's grab this at the end of this. If these counts are 3, then we have a winner. Let's test it. There we go. T dot print the board. It's empty. T dot mark space 0 0. And let's let the X's win this time. T dot mark space 1 1. No, actually let's do 2 2. So there's the board. There is no winner. So there we go. Now they have that diagonal. T dot get winner is 1. So cool. It looks like it worked. We can now check if that diagonal has caused a win. And as you can tell, this method getWinner is getting pretty long. And what we might want to do is separate these out into their own separate methods, but I'll leave that as an exercise for the viewer. Let's leave them all as 1 right here. So we've got one more thing to check for. We got to do this up diagonal. So let's look and see what those numbers have in common. So this one's not quite as simple as them just being the same. So what's the relationship here between the row and the column? Take a moment and look at that. So here you got 2, 0, 1, 1, 0, 2. What can we do to these numbers over here to get these numbers? Well, what if we did 2, minus whatever number we had. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 0 is 2. And what is this magic number 2? Well, that's 3 minus 1, where 3 is the number of rows and the number of columns. So this number, you could just throw 2 in there, but it's actually the length minus 1. And it's minus 1 because we started at 0. So let's do that. We can actually copy all of this. We're going to say check the up diagonal. We don't need to put in front of that. In fact, it'll give us an error if we do. And we use I again. It's not going to hurt anyone if we do. And the row is going to be the same, right? So row 0, row 1, row 2. But we don't want this here. We're going to want to put something else here. So we'll put the column. And the column is going to equal that 2, but let's go ahead and put what it is. It's the board length minus 1 minus I, whatever row we're at. So let's go ahead and do this to make it a little bit clearer what's going on. Okay, that's how you find the column. And everything else is the same. We don't have to touch it. So compile it. Forgot my semicolon. And let's go down here and let's test it. Okay. Print the board. Get the winner. There is no winner. Let's mark those spaces. So 1, 1. 0, 2. See if there's a winner. There isn't a winner. Let's print the board. So there we go. We just need to mark this one here. And let's do that real quick. That is 2, 0. Is there a winner? Yep, the winner is 1. Cool. So now we're checking all the different combinations through which you could win a game of tic-tac-toe. And we're returning the winner every time too. So we don't only know that someone won, we know exactly who did the winning as well. So that's it for this. And now we can uncomment our game over method. So if there was a winner, so let's just check that real quick. This is easy. If get winner equals 0. So if it returns 0, return true. We know the game's over because there's a winner. Or if it doesn't equal 0, sorry. So if it returns either 1 or 2, we know there's a winner, so the game must be over. Otherwise, it's going to return 0, and that means there's still empty spaces or no one has managed to win the game. As in, it's like a draw. And that's going to be this one here. So let's fill this in. So this is what we were talking about before we got sidetracked and started talking about that get winner method. So if there's a draw, so there's no more possible moves and no one won. So you got something that looks like apparently you can't go back any more than that. So let's just erase this one. Let's try to fill up this board without letting someone win. So it's O's turn. X, O, X. Okay, so we got a draw. And a lot of tic-tac-toe games are going to end like this, so it would be nice if we could also say this was a game over. So this just means that there are no more empty spaces, so there are no more space characters in our array. So we can use the for each loop. So for each row in the board, for each entry in the row, if the entry, remember we got to use dot equals, if it equals the space, then we know there's still a move left. So it's not game over. It's actually easier to check when it's not a game over than it is to check that it is a game over. So if we were to iterate through this thing and see that this was an empty space, we know that a player can make a move. It might not be a move that can win in the game, but it's still a legal move that they could make. So we don't even have to check these other ones. So just return false, the game's not over. And then otherwise, if you made it through the loop, like all the way through, and it never returned false, that means there were no empty spaces, so return true. I meant to put the semicolon in there. And that's it. Let's check that. So let's make ourselves a tic-tac-toe board. False. And let's go ahead and win the game real quick. Is the game over? True. So let's just recap real quick what we've done. So we used a 2D array to make a board. We created a method that checks if a space given the row and the column is free, meaning that it has this empty space character here. We created a method that allows the user, whoever is using our class, to mark a position in our grid. We created a method that checks if the game is over, meaning that there has either been a winner or there are no more moves. We created a getWinner method that checks if there is a winner, but also returns what the winner is if there is one, where 1 is X and 2 is O. So you can win on the across, the down, and both the diagonals. And then, last but not least, we wrote this method that allowed us to print out the board. And you can see why we did that first. This made it a whole lot easier for us to test our program and see that it was working as we'd intended. So I think what we'll do is we'll end this video here. I know this isn't a playable version of Tic-Tac-Toe, but this is everything that we're going to need to go on to the next part to actually make a full-fledged game. And I'll save that for a video of its own. So if you have any questions about this, I know I moved pretty fast. There's a lot going on here. Hopefully you're able to follow along, but if you have any questions, feel free to ask me, or even go back and maybe watch this video one more time. And I'll see you in the next video.